So my portfolio topic, which was the intersection between politics and technology, is something which the idea of creating knowledge is applicable every day. One of these examples is a theory I came up with over the holidays, the median Twitter theorem, which I think is an instance of this creating knowledge, how the intersection of these two fields can create new knowledge. The inspiration for this was a series of lectures at the University of Western Australia during their research week. The topic of these seminars was about the intersection between humanities and sciences, which is essentially my portfolio topic. It was followed by the International Conference for Undergraduate Research, which I was a part of. A couple of their seminars too were about my portfolio topic, which was an amazing coincidence. Or at least it just shows how new and how other people are thinking about this intersection. I think I further refined this theorem, the median Twitter theorem, which isn't really a theorem but more a theorem about a theorem, during the Science and Humanities Colloquium at the ANU. Further refined again by the ANU Tomorrow series of lectures featuring Ryan Goss and Brian Schmidt, who's from law and astrophysics respectively, and really helped refine my ideas about how knowledge is created in the intersection and how collaborative this process can be. So the basis for my median tweet theorem comes from two other models in political science, the median voter theorem and the Downs-Hotelling model. The median voter theorem states that if all voters' preferences are single-picked on a single dimension, then the bliss point of the median voter is a Condorcet winner, or has an empty win set. And they mean the same thing. This has a couple of technical definitions, so I'll go through them. They're on the screen. Single-peaked, see the graph for an obvious explanation, you'll see it's quite obvious. The bliss point is the ideal policy point of each voter. So each voter, they might have a policy preference on a one dimension, on a particular policy, and the bliss point is just the point which they prefer the most to all other points. The Condorcet winner, it's the bliss point which beats every other point if you were to compare them in pairwise elections. So if you had to vote on each point, which is the best point for policy, this would be the one that beats all the other ones. And then empty win set. A win set is the set of candidates which a majority of voters prefer to that candidate or that point. So for an empty win set, this should be empty. You can see this graph, it's quite obvious what single-picked means. It has a single pick if you plot the utilities versus the policy points. In this case, the median voter is voter J. As evidenced, it is the median voter, and if you were to have a vote on it, it is also the most preferred policy point, if you were to add all the utilities. The next model is the Downs-Hotelling model, which is very similar to the median voter theorem, and in fact, quite a few people get them confused. The Downs-Hotelling model is more like an application of the median voter theorem. So let's assume that we have this graph of people's policy preferences. Again, it's left to right as a simplification, and we have a graph of voters' preferences. So in this hypothetical scenario, we have more right-leaning voters. So the graph represents the number of voters whose bliss point is at that particular point in the spectrum. So over here, you can see that the median voter is slightly to the right, which reflects the distribution of voter preferences, and then we have our two parties, let's say Labour and Liberal, Labour being the more left party and Liberal being the more right party. Now, under this assumption, voters vote for the party which they are closer to in a election, in a policy. So, if you're closer to Labour on the policy spectrum, then you vote for Labour. If you're closer to Liberal, then you vote for Liberal on this policy spectrum. So then here we have the midpoint between parties, and if you notice, in this particular case, the midpoint is to the left of the median voter. Okay? Now, the Downs-Hotelling model shows that if you're able to capture the median voter, if a party is able to capture the median voter, that is, if it's closer to the median voter than the other party, then it will win the election. And why? That's just simple mathematics. The median voter represents the 50% voter, and to win you need 50% of the votes, obviously. So you need the median voter to win an election. In this case, you can see that the midpoint is to the left of the median voter, which means the Liberal Party captures everything to the right of that midpoint, and Labour to the left of that midpoint. Since the median voter votes for Liberal in this case, Liberals win the election. Now, these models are oversimplifications of real life. Most elections aren't based on one policy. There may be more than two parties. Sometimes voters' preferences may not be single-peaked. There's a whole lot of other factors involved. But this is just a basic factor, a basic model. So what the Downs-Hotelling model predicts is that over time, the two parties will converge onto the median voter. That is, they'll become more and more closely similar in terms of policy-wise, and until they both capture the median voter. And then it's just a random toss as to who wins, since they're so similar. This can be observed through this cute animation by my Polls 1002 lecturer, Andrew Banfield. So this captures what I want to talk about in the median Twitter theorem. Instead of voters, we have tweets or Twitterers, and we can rank them on a policy spectrum. Particular tweets at the graph would be a function of the number of tweets or Twitterers who can be placed on that spectrum. And it'd be very interesting to note if you could capture the median Twitterer, will that guarantee you an election? It is assumed that Twitter is a highly polarized area where the extremists are more likely to tweet about politics than the more moderates. So it is likely that the distribution would be more bipolar, like this graph over here. But note that if it's equally bipolar, then the median voter theorem still holds. That is, it may not be an accurate representation of society, but in terms of policy, it's still the median policy space for all of the population. But if it isn't, if, for example, Twitter is more left-wing or more right-wing than the population, then that would yield interesting results, and that's what I want to look at. In light of this proposed theory, I did some research and actually found someone who did a kind of similar thing at the Queensland University of Technology, Axel Brons and Jean Burgess, I think that's how you pronounce his name, and it was about Twitter and how it covered the 2010 Australian federal election. Their perspective was slightly different from mine. It was about the major issues prevalent in Twitter at that time, as well as the influence of journalists and politicians, how many times they were retweeted, for example, and as you can see here, the network of replies and retweets as a result of the OzPoll hashtag. And this is the kind of thing I want to do. So the script that they use to analyze tweets actually can be modified to suit my purposes. And this is the sort of research which I'd like to do.